Schmidt's rebound hardness test is the test to determine the rebound hardness of a test material by using the Schmidt impact hammer. The Hess rebound hardness value may be the index that will be used in the practice of rock mechanics to estimate the universal compressive strength and the modulus elasticity of intact rock both in the laboratory condition and in situ. The Hess can be used to estimating the usage of discontinuity walls and assessing the workability, excavatability, and bulkability of rock by mechanical. This device can be used in the laboratory and at the field.
The G4-2 Schmidt rebound hardness test. The straightforward principles apply when operating the Schmidt hammer, shown in Figure 1. Here, a constant amount of stored spring energy is imparted through a hammer mass to the plunger, causing the mass to rebound a distance proportional to the total energy absorbed by the impact surface. The rebound index is shown by the indicator and is defined as the rebound index. The degree of rebound varies depending upon rock elastic properties. The height of rebound of the mass is measured on a scale and is taken as the measure of hardness.
Firstly, we need to clean the surface of the rock using brush to make sure no dust on its surface. Then we place the plunger on the surface of the rock and make sure the rebound hammer placed perpendicular to the rock. This is to ensure the accuracy of the result of this experiment. Then push the rebound hammer until the click sound is produced. Simultaneously push the lock button, then record rebound value on rebound hammer.
For the result and analysis, this experiment needs to be conducted with 20 different points. So from these points, we obtain 20 different Reynolds number. So we already know the unit weight of sample rock, which is 26 kN per meter square. So we can define the compressive strength of rock surface using correlation between hammer unit weight and UCS graph. So from this graph, we already obtain the Reynolds numbers. For example, we have 47, so we elongate it upwards until it touches the 26 kilopascal line, and we stretch to the left to define the UCS value. So here we get 117 megapascal. So we need to do for each Reynolds number, and lastly find the average rebound value and average UCS value to determine the indicative rock types.
As the recommendation before the experiment to be conducted, it is important to calibrate the Schmidt hammer in order to get more accurate data or value. By adjusting the adjustment screw and nut on the cap of the hammer, use a wrench with suitable size. To choose a suitable rock for this experiment as a sample, the rock should not be weathered, otherwise it will crack in the middle of the experiment. For this experiment, the granodiorite igneous rock with 26 kN per meter cube as the unit weight has been chosen. Hexagonal crystal shaped with 100 mm size, and orientation of the hammer is 90 degrees vertically. As the conclusion for this Schmidt rebound hammer test, the hardness and UCS, which is uniaxial compressive strength, has been determined. The average of rebound number is 37.1 and the average UCS is 80.6 MPa.